today's class, we're going to talk about concentration of solutions, and then we're also going to talk about crystallization, which we both of which we briefly mentioned, to be fair, in the other class, in the previous class. Okay, so some keywords and notes here. The term concentration is used to describe how much solute is dissolved in a solvent. Okay, so if any of you continue on and do leaving cert chemistry, you will spend quite a bit of your time talking about the concentration of different materials. For one experiment, you might need very, very concentrated hydrochloric acid, for example, so that would be a lot of acid in a small amount of water, or sometimes for the experiment you just need a very dilute concentration of hydrochloric acid, which means you will have a very small amount of hydrogen chloride in a lot of water. And you learn how to make those solutions up at the different concentrations. Kind of early on in chemistry, your teacher will do a lot of it for you, but you do have to learn how to make a solution. So one being, no matter what they ask you, like they ask you solutions in terms of like molarities, which we're not getting into, but like, so you need to be able to make a 0.1 molar solution, you need to be able to make a 0.2 molar solution all the way up, and the higher the molarity, basically the more grams are being dissolved per litre. Yeah, so this is all just about concentration, and concentration is just about how much solute are you putting in and how much solvent is in there. Okay, so if you've got, like, here's my beaker, water, second beaker, same amount of water, so they're identical, let's pretend. And in the first one, this is your solute, and then in the second one, this is your solute. Okay, so they have very different concentrations. This one over here is much more concentrated. This one here is much more concentrated because there's an awful lot more solute in that solution, whereas over here this would be less concentrated. There'd be less grams per litre in this solution. Okay, this would be more grams per litre. So, more concentrated. Sorry. And over here you would have less grams of solute per litre of solvent, so less concentrated. Okay? So you don't say more and less concentrated, you have words for that. So the first one here is a dilute solution, and that would contain a small quantity of solute in a large quantity of solvent. So that would be this one here. Okay? This solution would be dilute. Okay, so if you dilute something down a lot, it means you're putting a lot of, you can go back there to like the blackcurrant or orange squash or whatever. If you put a lot, so you put a small little bit of blackcurrant in the bottom of your glass and you put loads and loads and loads and loads of water, it's going to be massively diluted. Okay, so the word has the same kind of connotations, I suppose, as that. Next one here then, concentrated. Okay, so a concentrated solution contains a large quantity of solute in a small quantity of solvent. So that would be this one. That would be described as concentrated. Okay, and the last one we did actually talk about, a saturated solution. That is a solution that contains as much solute as possible at a given temperature. Okay, so a saturated solution is when you are adding in over here, you're adding in your solute, and then let's pretend it's salt and water again. So you're adding in your solute, and then it just won't dissolve anymore. So you just have bits of salt sitting on the bottom of the glass. You have now reached saturation. So what you need to do is, do you remember the guy in the video did it? You need to use filter paper, filter off the bits that didn't dissolve, and then what's left is fully saturated. If you add another grain of sand, you add another grain of salt, it will not dissolve. It will fall straight out of the solution to the bottom because that solution is saturated. That liquid has dissolved as much solid as it is capable of. Now, we learned the other day that if you heat it, it will dissolve more. So that's why this says at a given temperature. Okay, so if you're not going to mess with the temperature, all you have is your beaker of water sitting on the desk and you've thrown the salt in. When the salt starts to gather at the bottom, you then filter off that solid salt, and then what you've left is a saturated solution where that liquid has dissolved as much solid as is possible. Okay? So there's a little kind of like little diagram here. So a dilute solution, a dilute copper sulfate solution. So copper sulfate, they're like little blue crystals. We have them in the lab. So here you'd have just a few little blue crystals with lots and lots of water, and make a nice light blue. And then if you add more copper sulfate, so if you come in and you add more copper sulfate, you have concentrated copper sulfate solution. And then if you keep adding the copper sulfate, it will become saturated. That kind of gradient makes sense. So dilutes down here, small amount of copper sulfate. If you put more in, it will become a concentrated copper sulfate solution. And if you add yet more, it will become saturated, where the water can't take any more. And all the little crystals are set at the bottom. Is that okay? So those words are important that I need to go into your notes. Crystals are tiny solid particles that often form regular shapes. So I think when you hear crystals, you think of like, I don't know, fortune teller looking into, like you think, like it has examples there, salt, snowflakes and diamonds. I think you kind of think more along the diamonds when you hear crystals. But anything that forms a regular shape is called a crystal. So you can make crystals out of, like, I'll show you now, but you can make them out of all sorts of different things. So it's just that regular shape. Like if you were to look at salt under a microscope, salt is little crystals. They're very very organized structures. And we saw in the experiment the other day, do you remember your man put the salt into the water and he heated it up to like 94 degrees or something like that, and then he put it put it into the freezer, and then when he took it out of the freezer you could see all the salt on the bottom. Okay, so that was crystallization. That was where the salt was dissolved in the water because the temperature was high enough to hold that much salt. But once you reduced the temperature of the water by putting it into the freezer, then that water's solubility went way down. So it just wasn't able to dissolve any more salt. So it started pushing the salt out of the solution, and then the salt formed on the bottom of the beaker as crystals, and that's crystallization. Okay, so that process we kind of watched the other day. We just didn't talk about the words around it. So crystals are formed by cooling a saturated solution. Okay, so if you have a solution that is saturated, which means it can't take any more of the solute, so like that salt, remember he put the salt in, heated it up, and then he still had a couple of crystals at the bottom, so he filtered them off. So the solution was saturated, couldn't take any more salt. He then put it into the freezer, reduced the temperature, and the salt crystals reformed. Okay, that is because the liquid had cooled and could no longer dissolve the same quantity of salts. So you get crystallization. So we're going to watch this. I think I have to scroll down to get it. So we would have done this, okay, in school. Had we have been there? I think this is it.
There are some things you just can't just.
This is annoying. Oh, here. Okay, is this it? Okay. Okay, so you can try it with, I mean, if you have Epsom salt's fine, but you can try it with regular salt as well if you want. You obviously don't need to. So that's literally just kind of I suppose, a nicer version of the exact same experiment that was done the other day, where the salt was put in and then put into the freezer. He just didn't colour it, and I think Epsom salts, they're smaller grains, so they make nicer crystals, as far as I remember. But anyway, so the all you need to understand is the process of crystallization. Like, why do you get the crystals? Okay, so you get the crystals because they were originally dissolved in the solution, but the solution was cooled, or they were originally dissolved in this solvent, but the solvent was cooled. That solvent could no longer dissolve as much solute as before, so the solute gets pushed out of the solution and it crystallizes on the bottom of the container. Okay, so that's all I want to do today. So there's a couple of keywords there, and then there's actually a really nice bit of homework on understanding concentrations. Okay, so give it a go. Hopefully you get it. And that's due for Tuesday. And I think then we just have Tuesday and Thursday, and then you're kind of into tests. So I think, I know I had chapter 15 on the list, but I'm just going to try and finish this chapter, chapter 11. I'm not going to try and push to finish chapter 15. So we'll call it a chapter 11. Is that okay? I should have that, like, we're nearly there. This is nearly the end of the chapter, so hopefully I'll be able to finish it on Tuesday. And then if you want, we can try sometime next week to arrange a... Have I got that? Are the dates right there? Sorry, I'm just checking the calendar here now. Yeah. So Thursday, and then we've next Tuesday and Thursday, and the following week is your exams. So yeah, I'll try and I'll have a look at the chapter now and see if I can get that content finished on Tuesday, and then any time in the week, Wednesday, Thursday, Friday, we can have an online class, if any of you have questions you want to throw at me on any of the chapters ahead of your summer exam. Okay. Have a good weekend.